If you're a fan of classic arcade games, then this is the perfect project for you. So let me show you what we'll be making today. Hold up finished console. Right, yeah, here. As you can see, it's a handheld Pong console that you can play anywhere. So I do want to get one thing out of the way. This is so easy to make that if you have access to a 3D printer or some electronics equipment, a soldering station, and access to online resources, you can make this. In fact, the code was made in tandem with ChatGPT, and even the script for this video was also made by ChatGPT. So, let's get started. Let's get the first thing out of the way, the most important thing, the electronics. We have for the actual microcontroller, the Arduino Mega 2560. I will be showing you how to wire everything to this microcontroller, but keep in mind you can easily use any other microcontroller that you can interface your display to. For example, an easy microcontroller to interface the display I have is the Arduino Uno. The I/O pins are almost exactly the same as the Mega 2560. Additionally, you can use pretty much any Arduino platform, such as, for example, the Nano. Now, this one doesn't directly interface to the shield. However, if you have your own shield that you can design or some other display, you can easily use something with a smaller factor. However, for the purposes of this video, I will be showing you how to interface it to this microcontroller. Moving on, we've got the wires. Now I will be using the Arduino standard wires. They are thin enough where they don't really kind of mess with any of the internals. They fit very nicely, but they're thick enough where they don't heat up from the amperage. So I do like to use them even though that's not what they're designed for. They're also great for prototyping whilst you're in the stages of developing the product before you actually solder everything together. However, they are very easy to kind of cut and tin and solder once you actually get to that point. Right, now the important interfacing electronics there's quite a few. You have your main switch. This is your power switch. I like to go flashy. The whole point of this project is to make it look apocalyptic, like something out of a Blade Runner movie. So I've chosen this red switch here. It looks like it's out of a submarine or something. Now I've wired it here to the actual power block. What I'm using here is, first of all, a battery pack here, which holds 4 AAA batteries. This outputs about 6 volts, which is a little more than Arduino needs, but I mean, it's got a limiter there. It's exactly the right size for the project that we're making. I've wired it to the switch so I can kind of analog turn it on and off to make that cool little effect. And finally, you've got the actual power to the microcontroller. I just cut down the power switch, the USB cable that it came with. Archaic, I know, you could do it in a different way. You can wire it to the pins directly. This would be a cleaner way to do it, but I mean, frankly, this works. So, and frees up space for more pins to be used and an extra ground pin. So if it works, why not use it? And finally, you've got these potentiometers. This is what you're actually going to be playing with. This is your input device. I have the power and the ground soldered together, and I have this terminal block where I soldered the connection pins too. But yeah, that's the basics that you were going to need in terms of the wiring. Finally, the electronics you're going to need that is the most crucial is the actual screen. I will be using the Elegoo screen. This is a 2.4-inch touch display LCD screen. It interfaces directly into the Arduino Mega. Has all the pins in a nice shield here. So yeah, that's what we're going to be playing the Pong game on. And finally, once we have everything out of the way, you clear it up, we've got a little bit of our own soldering to do. Now I promise you won't have to do too much. But here we have a breadboard, and let me measure it for a second here. The design, the model of the casing has a housing for this specific size. It is about 30 by, I believe, 70. Let me check that, what we have here. Yes, 70 millimeters. This is only going to house terminal blocks like these ones right here. You can focus on that. Yeah. We're going to be soldering those together. I will be showing you how to do that. And finally, you've got some power wires that I will also be showing you how to make this and connect it to the Arduino as well. Finally, and only for comfort's sake, you're going to be needing some precision tools. Anything that has a hex nut and a few Phillips head screwdrivers will do just fine. I mean, you don't really need any special adapters for that. Here's something that you don't necessarily require for this to work, but I've found that it helps a lot to make semi-permanent to permanent wiring for my product. Here we've got these terminal blocks. They're not like the blue ones. They just connect to the pins on an Arduino. They're very simple to solder the wires onto and connect to the Arduino in a more secure fashion. Don't remember how they're called, but they're very useful. I will be showing you how to use them in a very ghetto way, but it works. I mean, in an apocalypse, you do with what you have. And finally, you have these shrink wrap. Now, these are crucial for, again, making more permanent wiring. So everything kind of, first of all, is more neat when you're wiring everything together and fitting it into the casing. But also, it adds a little bit of that rigidity and longevity. So yeah, you don't have to use this, but I found that they, first of all, increase the quality of your product a lot, and also make the durability something out of, well, I don't know, a post-apocalyptic sort of world where you'd find this 1972 Pong game. Let's get into the fasteners and all the extra bits that you might need. Now, I've already shown you that you're going to need a battery module. Now, with the battery module, you're going to need the actual batteries themselves. And usually in the set, you are provided two little screws. They fit perfectly with the CAD model that I've provided. That's why I didn't label this pack, but in case that I find what size they are, I will label them down in the description. I will also link in the description all the sizes of the holes for the base plate, so don't worry, you won't get any mismatching parts with tolerances and all that. And now comes the actual screws, which I have labeled because I actually know what their dimensions are. Here, you've got two pieces of M3 by 6. These are going to be bolting your microcontroller, the Arduino Mega, to the base plate. Next up, the M3 by 35 millimeter hex bolts. These are 5 pieces. I'm going to bolt down the entire assembly of the casing together. And finally, to secure the handmade sort of PCB that you made with the development board and the terminals, you've got 4 pieces of M2 by 6 millimeters hex screws here as well. And finally, you're going to need a bottle of water. This has nothing to do with the Arduino. It's just your daily reminder to stay hydrated. As for the plastics, I'm going to be using this eSun Black PLA+. You can easily use any other hard plastics to print the main housing, but for the purposes of this video, this is what I'm going to be using. The gasket in my case is printed in Overture's TPU. This is a flexible filament. You can use any other flexible filament with no issues so long as your printer can handle it. At this point, you're going to need to print all of the parts. Printing will take no more than 20 hours, so you should be done by the next day. It is now the morning of the next day. Ideally, the whole print sequence should have taken less than 20 hours, so by now, you should have had all the printed parts ready. I've got mine in my magic box here. The front plate, the TPU gasket, the walls, and the back plate, as well as 2 potentiometer knobs. Now to the assembly. First, let's install the battery pack. Once we have that installed, let's assemble our own PCB with the terminals. Now let's put this onto the front plate and the back plate. Now that we have that out of the way, let's put in the pièce de résistance, the actual microcontroller. Once that's connected, we can now proceed with the main power pins for the potentiometers. And finally, the potentiometers themselves. Now, squashing everything together, we gotta get the side walls into the Arduino. Since the spacing is really tight, I would recommend to actually first plug in the power and make sure you have all of the wiring actually done before you do this, because it's a little bit of a tight fit. Now, assembling the front plate may be a little bit gimmicky. If you've ever assembled a guitar, you know that you put the potentiometers onto the front plate first and then actually assemble it to the base. It's very similar with this. Alright, now that everything's assembled, there's only one thing left to do. The design process of this project was made easy thanks to user-friendly CAD software, Onshape. Although it should be noted that other software such as Fusion, AutoCAD, or SolidWorks can do just as good a job at a project such as this. I chose to use Onshape for its ease of use and accessible public domain. So here we have Onshape loaded up. Again, not sponsored by Onshape. However, please sponsor me. That would be absolutely great. Here in public, I've named the file Pong from that one video really specifically, so you can find it in public space. You could just search up Pong from that one video. Yeah, I really hope that that's the only one that you can find there, and it is. You could just open that up and download everything as STL or change anything. I will be providing the STL files and the link to this file just in case in the description. But yeah, here you can find the files that I made. Here's the base plate and everything. If you do want to change any of the dimensions, you can easily do that through here. As for the code, this was done in conjunction with ChatGPT, as I have said. So let's open that up and full screen it as well, so you can see it better. This is a work in progress for the most part, mainly due to this. I was trying to add a buzzer. That didn't really go as planned, so I decided to just end the project as is. However, in future, I guess, iterations, it would be useful to add modifications. Any changes that are going to be made, if they're done by the time that this video is posted, I will be posting in the description. But this is the code that we have developed, me and the AI, together. Again, this I will be providing down there in the video. And just beside that subscribe and like button. So if you find this, you could just copy and paste it into your own Eno file. Upload that to Arduino Mega. Make sure you have the right board, and make sure you have the right bootloader or programmer in there. And it should just burn it onto your Arduino, and it should work as it should. So yeah, I guess that's it in terms of the software. Let's now go back to the workspace, and I can show you one final surprise that may put a smile on the faces of those who lived in the golden age of computer games. Also, and I know this is the moment that you've been waiting for, we have to actually test how the game works. Alright, now that everything's assembled, there's only one thing left to do. Archon, can you please pass me the printer?
Yeah, sure.
Mr. Cameraman? Okay. Let's connect this thing. Now that's parsing. All right. So now we've got that. We can stick it on here. Yeah, I think we've got to cut it down to size. That fit? I guess just a little more. Yeah, I think that looks good. Take that out of the way. All right. Stick that on this way. Fantastic. Just like that. Now you have your 2-player game of Atari. And with that, the project is finally complete. I can definitely say that it was quite a fun journey, albeit the road was certainly bumpy and full of errors. It pulled through nonetheless and was absolutely worth the result. This is officially my first project that I have ever posted. It marks the beginning of my channel, and I hope it sets a high bar for future endeavors. I'm open to discussion for this, so if you have any suggestions for what I should make next, please let me know in the comments. Thank you for watching.